What if reality isn't seamless but cracked? Not metaphorically, but literally. What if, deep beneath everything we touch, see, or measure, there's a hidden fracture, a kind of cosmic glitch that no theory has been able to seal? For over a century, physics has tried to describe reality as if it were a perfect equation, smooth, logical, complete. But in 2025, whispers from several quantum experiments are suggesting something heretical, that the universe might be fundamentally incomplete, that space, time, and even causality could be leaking through a hidden flaw in the fabric of existence. It started quietly. In ultra-precise quantum field measurements, researchers noticed energy mismatches, infinitesimal deviations that shouldn't exist. The kind that the math calls impossible, but they persist, they repeat, and they suggest that quantum mechanics itself might be brushing up against something beneath it, a deeper, unquantized layer. Imagine the universe as a flawless mirror, reflecting every event perfectly. But now, under the right light, that mirror shows a crack, so thin you could mistake it for light itself. And through that crack, something else peers back. Not another world, but the missing logic that underlies this one. This isn't science fiction. It's being debated in labs and conferences right now. Some call it quantum decoherence instability. Others call it vacuum anomaly drift. But more and more scientists are daring to ask a forbidden question. What if the universe was never meant to be stable? What if we've just discovered the first fracture in the code that holds existence together? And if that's true, what's on the other side of that crack? Let's pull back the curtain. What exactly is this quantum crack scientists think they've found? It begins with something deceptively simple: energy conservation. In quantum mechanics, every process must balance perfectly. The total energy before and after a reaction remains the same. But in a series of ultra-precise vacuum tests, particularly those involving the Casimir effect and zero-point field fluctuations, physicists have begun to notice infinitesimal leaks of energy that can't be explained by standard quantum electrodynamics. The vacuum, it seems, isn't empty. It's boiling with invisible energy, what we call quantum fluctuations. Particles pop in and out of existence, borrowing energy from the void and returning it milliseconds later. It's the heartbeat of the quantum world. But what happens when that energy doesn't return perfectly? What if some of it escapes? This is where the anomaly begins. Experiments in 2023 and 2024 from CERN's precision interferometry setups and the University of Vienna's quantum cavity labs have measured deviations so small they were once dismissed as noise. But when they lined up across different setups, across continents, they formed a pattern, a drift. Physicists started calling it the quantum crack hypothesis. The idea, space itself might not be continuous. Instead of being a smooth, uniform fabric, it could have microscopic fissures, points where the equations of quantum field theory fail to describe what's happening. These fissures could allow energy, or even information, to bleed into domains we can't detect. Not alternate universes, but unquantized regions of existence outside the mathematical map of our reality. It's as if the universe's pixels are misaligned. Most of the time, the simulation, if we can call it that, runs smoothly. But at the tiniest possible scale, the Planck scale, the code might glitch. The constants that define everything, the speed of light, Planck's constant, the charge of the electron, may be subtly fluctuating because the underlying grid isn't perfect. And if that's true, then the laws of physics aren't truly laws. They're approximations, statistical illusions drawn from a fractured foundation. Some physicists even speculate that dark energy, the mysterious force accelerating the universe's expansion, might be leaking through these quantum cracks, energy seeping in from that unquantized beyond. But that raises a terrifying question. If something can leak in, could something also leak out? Could reality itself be slowly losing coherence? Not metaphorically, but literally, like a painting that's beginning to fade at its edges. Because if these cracks are real, the universe may not be eternal. It may just be holding together for now. And the next question scientists are asking could rewrite everything we know about existence itself. Let's admit it. We've always trusted reality to behave. Drop a ball, it falls. Touch fire, it burns. Switch on a light, photons travel in straight, predictable lines. But that quiet trust, that invisible contract between our senses and the world, depends on one assumption: that reality is continuous, stable, and complete. The quantum crack hypothesis shatters that assumption like glass. Because if these new anomalies are real, then everything we perceive might be built on a fractured substrate, a patchwork of stability floating over gaps in the fundamental structure of existence. Here's the part that's hard to accept. This wouldn't just mean there are errors in our math, it would mean causality itself, the very idea that one event leads to another, might be only approximately true. The illusion of smooth cause and effect could be the result of our brains averaging out the tiny disruptions caused by these microcracks. It's like watching a high-definition video that's missing every 1,000th frame. You don't notice the gaps. Your mind fills them in. But the truth is, the footage isn't continuous. Something is missing, and your perception is doing the heavy lifting to hide it. Now imagine the universe doing that. Every interaction, every particle exchange, every quantum fluctuation filling in what can't be perfectly computed by the underlying fabric. That's the shocking implication here, that reality, in its rawest form, may not be self-consistent at all. The idea horrifies some physicists. Because if there's a fundamental discontinuity in the laws of nature, then the concept of truth itself becomes unstable. You can't build a perfect theory on an imperfect foundation. Every measurement, every observation, every equation might be, in the deepest sense, a kind of approximation of a broken whole. Think about what that means for everything we believe is solid: atoms, space-time, even logic. These cracks could explain why quantum mechanics and general relativity, our two greatest theories, refuse to merge. Maybe they don't fit together because there's nothing continuous to connect them. Reality itself could be non-continuous, flickering between describable states like a cosmic strobe light. And maybe, just maybe, that flicker is what we call time. Not an unbroken flow, but the rhythm of an unstable system holding itself together moment by moment. But if the cracks are widening, even by the smallest degree, it raises a question that sounds impossible to answer. If reality can break, who or what is keeping it from collapsing completely? Because the next evidence ladder might show us that the universe isn't just cracked, it's actively repairing itself in ways we don't yet understand. We're climbing the 4-step ladder of evidence that supports the idea of a quantum crack in existence. Each step builds, each more unsettling. Step 1. The vacuum energy puzzle. Physicists long ago recognized that the vacuum isn't nothing. Even empty space vibrates with quantum fluctuations, zero-point energy, a seething quantum foam. The predicament, theoretical predictions of vacuum energy, and thus the cosmological constant, are up to 120 orders of magnitude larger than what we observe in our universe's large-scale expansion. That mismatch suggests something fundamental is missing in our understanding of how empty space works. The baseline of reality might not be stable or complete. Step 2. Anomalies in vacuum stability and metastability. More recently, the notion that our vacuum state might be metastable, a false vacuum rather than absolutely stable, has gained traction. If the vacuum is metastable, then the ground of reality isn't rock solid. It may be teetering, capable of transitioning into something else. This introduces the first crack. If reality at its base can shift or leak, then the rulebook we assume might be provisional. Step 3. Dynamical anomalous vacuum contributions. There are studies showing that quantum anomalies, gravitational or conformal, can contribute to vacuum energy in ways that standard quantum field theory doesn't anticipate. For example, the trace anomaly in quantum field theory in curved spacetime suggests the vacuum energy depends on large-scale boundary conditions, not just microscopic Planck-scale physics. That means the vacuum, and hence reality, might be reacting to global structure rather than being a passive background. The suggestion, reality's foundation, is dynamic, unstable, and inscrutable. Step 4. Cracks as leaking constants and fluctuating foundations. Now we reach the most provocative step. If the vacuum energy is misaccounted for, if our lowest state is metastable, if anomalies can shift the baseline, then the constants we take as rigid, speed of light, Planck's constant vacuum permittivity, might themselves be slightly shifting or leaking. Even more, the space-time fabric might contain microscopic fissures where the usual mathematical rules break down. In short, the underlying grid of reality may be cracked. And that leads us to the cliffhanger. If the constants, the vacuum, the flat baseline of existence are not stable, then what's keeping reality from unraveling entirely? Here's where things stop being purely physical and start becoming existential. Because if reality truly contains a crack, a structural flaw in its own foundation, then everything we believe about truth, order, and permanence collapses into uncertainty. Think about it. Every philosophy, every religion, every moral system has been built on one hidden assumption: that the universe exists, that it's coherent enough to contain meaning, cause, and consequence. But if existence itself is unstable, if it's built on a shifting vacuum, an incomplete code, then truth might not be an absolute property. It might be a temporary agreement, held together by the stability of the quantum field at this very instant. This shakes even the foundations of epistemology, the study of knowledge. What does it mean to know something if the substrate of knowing can fluctuate? A fact could, in principle, stop being true not because it was wrong, but because the universe's parameters changed just slightly. In other words, truth itself could be time-dependent. Some scientists and philosophers have started calling this the ontological fragility principle. It suggests that what we experience as continuity, of time, of matter, of self, is more like a system under active correction, a kind of cosmic self-healing algorithm constantly reasserting order against microscopic chaos. The laws of physics might not be eternal decrees, but feedback mechanisms designed to repair these quantum fractures as they appear. That interpretation carries a terrifying elegance, because it implies that the universe knows, in a mathematical sense, that it's broken and spends its existence trying to hide it. Every stable atom, every predictable sunrise, could be evidence of a repair cycle, a cosmic patch job to keep the illusion of permanence intact. But not everyone buys this. Critics argue that calling it a crack anthropomorphizes randomness, that these anomalies might just reveal the limits of human measurement, not the limits of reality. They warn that we risk confusing epistemic uncertainty, our inability to know, with ontological instability, reality's inability to be. Still, others see it differently. If there is a quantum crack, a flaw in the machinery of being, then that very imperfection might be the source of everything that moves, changes, and evolves. In a perfectly stable universe, nothing could ever happen. Maybe the universe needs its cracks, the same way a seed needs a fracture to sprout. Because if perfection were possible, there would be no time, no growth, no consciousness. Imperfection might not be the bug in existence. It might be the feature that allows it to exist at all. But that thought leads to a haunting next step, one that blurs the line between physics and purpose. What if consciousness itself is born from this flaw, the living reflection of the universe trying to understand its own instability? If the quantum crack hypothesis holds even a grain of truth, the implications stretch far beyond theory. It could redefine physics, computation, cosmology, and maybe even consciousness itself, because a universe with structural flaws isn't broken, it's programmable. Think about what this could mean for quantum technology. Today's quantum computers rely on coherence, the fragile superposition of qubits that collapses when disturbed. But what if those disturbances aren't just noise, but signatures of the underlying crack? What if we could map them, read the error patterns of the universe itself, and use them as computational shortcuts into deeper layers of physics? Several research teams are already unknowingly brushing that edge. In late 2024, a team at the Perimeter Institute proposed a model where fluctuations in quantum decoherence could act as a natural random oracle, a way to tap into physical randomness beyond conventional probability. If true, future quantum machines might not just simulate reality. They could interrogate it, asking the vacuum how it wants to behave next. Imagine AI systems trained not just on data, but on reality's raw instability. Machines learning to surf the quantum crack, predicting how matter might deviate from its own laws. This could open new domains of discovery, self-correcting materials, time-sensitive communication, perhaps even technologies that sense reality's health the way a doctor reads vital signs. And then there's cosmology. If dark energy really is the pressure leak from those cracks, it could mean the universe is expanding not because of an external push, but because existence itself is losing cohesion at the edges. Every galaxy receding might be a symptom of deeper instability, space-time thinning where the quantum mesh fails to repair itself. But here's the thought that terrifies even the optimists. Cracks grow. If this instability accelerates, if the universe's repair mechanisms weaken, then one day, the constants that define existence might begin to drift faster. Chemistry could fail, gravity could vary, time could stutter. Not in some apocalyptic explosion, but in a gradual fade, a quiet unwinding of the equations that once held everything together. And yet, there's another view. Maybe this instability is the engine of creation itself. Maybe new universes emerge through these fractures, bubbles of repaired reality budding from the cracks of an older one. The quantum crack wouldn't just be a flaw, but a womb. Still, one question burns through all of it. If reality can fracture, who or what keeps reweaving it? Are we just passengers on a self-correcting code, or participants in maintaining it? Because the next discovery might not come from telescopes or colliders, but from us. And if consciousness is tied to that repair, if we are part of reality's immune system, what happens when we finally look directly at the crack itself? Let's bring this back to you. Not the universe, not the vacuum, not the equations. You. If reality itself contains cracks, then every second of your life is happening inside something unfinished. Every thought you have, every emotion, every memory, all of it is balancing on a surface that isn't fully stable, and yet somehow it holds. Somehow it works. Somehow it means something. That's the miracle we never talk about. You don't need a perfect universe to have a perfect moment. You just need a universe that doesn't collapse long enough for meaning to exist. Maybe that's the secret. Meaning doesn't arise despite the cracks, but because of them. If reality were flawless, everything would be frozen, predictable, static, no creativity, no discovery, no choice. It's the imperfections, the slight fluctuations, the tiny uncertainties that allow the new to emerge. You are, in a way, a conscious echo of that same instability. You adapt, you shift, you reassemble yourself after every failure, every emotional crack. You are a microcosm of the universe's imperfection and its resilience. Now think about what it means if your mind, your awareness, your ability to observe is part of that self-correcting process. Maybe consciousness isn't an accident within the universe. Maybe it's the mechanism by which the universe holds itself together. Every act of observation, every moment of awareness could be a contribution to cosmic stability, reality observing itself to stay real. That thought changes everything. It transforms existence from passive to participatory. You're not floating in an indifferent cosmos. You're helping it cohere. Your curiosity, your wonder, your awareness, they might literally be acts of repair. When you learn, when you love, when you notice something deeply, you're reinforcing the structure that allows it all to exist. And maybe that's the quiet purpose that hides inside the crack. Not to eliminate imperfection, but to engage with it. To be the consciousness that holds the broken mirror steady enough for light to pass through. Because maybe the universe doesn't need to be fixed. Maybe it just needs to be seen. If that's true, then every act of awareness is sacred. Every question, especially the impossible ones, is a contribution to the universe's continuity. But that brings us to the most personal mystery of all, one that goes beyond science, beyond philosophy, into the territory of the soul. If we are part of the universe's repair, what happens when we finally understand the flaw itself? Do we disappear with it? Or transcend it? Maybe that's the paradox of it all. The closer we get to understanding the crack in reality, the more we realize it isn't something outside of us. It's within us. The flaw in existence isn't a defect to fix. It's a mystery to live inside of. For centuries, humans searched for perfection. In science, in gods, in themselves. But maybe perfection never existed. Maybe the crack is the truth. The line between chaos and order, between what is and what could be, the thin fracture through which creativity, consciousness, and existence itself pour. If you zoom out far enough, everything becomes symmetrical, galaxies, equations, probabilities, but zoom in, and you find the irregularities, the unpredictable, the unrepeatable. That's where life hides. That's where you hide. The quantum crack may be the universe's confession. Its way of whispering that even reality doesn't fully understand itself, that it's still learning, still forming, still daring to exist. So when you look up at the night sky, don't see emptiness. See the tension holding it all together. See the flicker in the distance as proof that imperfection is eternal. And that's what makes existence possible. Maybe one day science will find the mechanism behind it. Maybe we'll discover what the crack really is. A dimensional boundary, a computational limit, a metaphysical interface. Or maybe we'll never solve it because the act of observing it changes it. But either way, the flaw remains the invitation. To keep asking, to keep watching, to keep being. Do you believe this quantum crack is the first glimpse of a deeper reality? Or just another illusion in the cosmic code? Tell me below. Your view might change someone's mind.